All right, welcome back, guys. So our next video for the calculator tutorial is going to focus on some skills that you're going to learn in the calculus class. And we'll use this as kind of an introduction to the overall ideas without getting into too much of the detail. There are a lot of other skills that are here in the OneNote that if you're interested in or you have extra time, you might want to go through and work through some of those examples so that you can become more comfortable with your calculator. But the ones that we skipped are skills that don't necessarily apply to the AP Calculus test. If you're not familiar with them and don't have time to do them, then you won't be at a severe disadvantage. All right, so what I want to talk about a little bit is the structure of our class. There are two main ideas for calculus in our class that we're really going to focus on through the whole year. And the first one is differentiation. And the second one is integration. The way this course is laid out is the first semester of this course, we're going to focus on differentiation. And the second semester of this course, we focus on integration. Within that, we start by analyzing and learning the rules that we need to know to verify that it is possible to carry out this action. Then we're going to learn the exact definition of differentiation. Then we'll learn tips and tricks to do the process quickly. And then we'll learn applications, how it's used in different fields like physics, economics, biology, so on. The second semester of the class is going to have the same structure. We'll learn the basic rules that we need to know to verify that it's possible to carry out an integration. Then we'll learn the conceptual idea and definition of integration. And then we'll learn tips and tricks for doing integration quickly. And then we'll end with applications. There are three main focuses for this class. So everything we do, we'll need to be able to do in three different ways. The first way is algebraic. This is what you're used to, manipulating things with a pen and paper using variables and symbols. The next way is numeric. This is where you might be given a table of data and you need to use the ideas of calculus to perform operations on that table of data. And the last way is graphical, where we understand what we're doing in calculus by relating it to graphs of different types of functions and the visual representation of what we're actually doing. So it's very important that every single concept we talk about in the class, that we can understand that concept in all three ways. Depending on our background, one of these three might be a strength for us and we'll tend to rely on it. And what ends up happening is that when we take the AP test, if we have a function that gives us a table of data, or we have a function that gives us a complicated graph, we end up not doing very well because maybe we just focused on the algebraic stuff. And part of that tendency is because the classes you've had in the past probably really stressed algebraic manipulation because you were learning how to do those things. So we really need to branch out from that. Anyway, so let's talk. I want to give you just a very, very low-level conceptual introduction to integration and differentiation. So let's talk about the derivative. The derivative of a function gives instantaneous rate of change. So if I had a graph of position and time, and the object was moving like this so that its position started at 0, and over time it exponentially increased its distance away from us, the derivative would be the instantaneous slope of that line at any point. That's our conceptual understanding of what's going on. And you'll notice that because it's a curved line, the slope of that line is changing. Right? The slope of this curve is changing. So the rate of change of our position is changing over time. A geometric representation of a derivative is the slope of a tangent line, which is drawn there to kind of exaggerate the slope for you so you can see what that slope is. So that's a derivative. It can help us understand the instantaneous rate of change. A physical example of this would be the derivative of position, let's say displacement, with respect to time which is the graph we have drawn up there, is velocity. If the derivative is the instantaneous rate of change, then that's our velocity. Think about you being in a car and you're speeding up as you go on the on-ramp to a highway. Your position is changing as you speed up, and the speed that your speedometer in the car is showing you is constantly increasing. So the derivative of your position, the position of the car, is that constantly changing speed, in this case velocity. And we'll talk about the difference between speed and velocity when we get to it. But that's what the word instantaneous means. We know our velocity is changing all the time, and the derivative can tell us, based on our position function, what our velocity was at any particular time. And let's talk about the integral. So the integral. Let's say that we have a velocity time graph, and we have some function. If we were to take the integral from one point to another, what we're doing is finding the area under the curve. From A to B. That's our graphical representation, just like the slope of the tangent line was our graphical representation. The integral represents the change of the antiderivative. So in this case, the area here Now, antiderivative means opposite of derivative. So when we took the derivative of displacement, we got velocity. So the opposite of that would be to go from velocity back to displacement. So this area represents the change in displacement. That little delta, this delta symbol here means change. So change in displacement, that would be our physical representation. Let me change this to red here real quick. So what I want to show you is on the calculator how to do these calculations. Okay. So we're going to turn on our calculator, and let's go with the graphs we had before. So we're going to turn on these two graphs. We're going to turn off this horizontal line. And actually, why don't we start with just the parabola? So we'll graph that real quick. Okay, so I can go into Calc. Do it. And this is the symbol for the derivative. So I can take the derivative, and let's say I want to find the slope. Visually, I can kind of tell that the slope at the bottom of that parabola should be 0. So I can take the derivative, put my cursor where I want to take the derivative at, and it should tell me, there we go, the slope is 0. We could do it again and move it somewhere. The slope over here should be positive. And there we go, we get the slope is about +3. We can also take an integral. This bottom one is the symbol for an integral. So we can, let's take two places. So our lower limit, we'll just put it there. And our upper limit, we want to find the area below the curve in these two regions. You can see it shades it in for us, and it tells us the value of that area, the area of that shaded region. So that works out really well. Let's try it one more time. What if we do our limit down here? So we go from here to the 0. It's going to shade that region in. Look, our area is negative now. So when the area is below the x-axis, it's negative, and when the area is above the x-axis, it's positive. We could also do these calculations without the graph. We can go to Math, and there is 8 and 9. This is numeric derivative, numeric integral. So we can say 8, and we can say we want to take the derivative with respect to x of, let's just put in a parabola, x squared. And we want to evaluate it at some place, 5, and we get our answer. We could also take an integral, so we should go Math, 9. And let's say we want to take our integral from 0 to 1 of a parabola. Oops. We want to take that with respect to x. So here what I'm showing you is this is the algebraic version of what we were just doing graphically. And that's going to give us our answer. Now, understand that we will spend an entire semester talking about derivatives and an entire semester talking about integrals. So if some of this is a little bit alien to you, that's totally normal. All I want you guys to practice tonight with the problem set is using your calculator to find these answers and just try to develop a general understanding of what they mean.